Hello, I'm Mr. Tormoehlen, middle school math teacher. This week's Ask a Teacher problem was submitted via Facebook, and it is a version of a classic probability problem. And the problem states, what is the minimum number of students that must be in a classroom so that there is a 50% chance at least two of them will share a birthday? And like any good problem, sometimes it's a good idea to try to make an intuitive guess. So take a second, guess what you think maybe this answer will be, and then pause the video and then restart it, and we will show you what the full solution and the right answer is to the question. The key to solving this question is to start small and try to figure out what would happen with a couple of students and then build from a full solution from there. So if we had two students in the classroom, the probability or the chance that they would share a birthday is very easy to calculate. You take the first student and it doesn't matter what birthday they have. And then you look at the second student and you say, what is the chance that that second student has the same birthday as the first student? And there are 365 days in a year, and so the chance that the second student has the same birthday as the first student is 1 over 365. And so that's very easy. One way we could think about it is, which will help us later, is the first student, they could have any birthday they wanted, and then the second student must have the same birthday as the first student. So 365 over 365 times 1 over 365. This turns out to be right around 0.27%, obviously very far away from 50%. Now, as soon as we get to 3 students, it gets very hard because there are a lot of cases. And the cases are A and B sharing a birthday, C not sharing a birthday. So person A and person B sharing, C not sharing. A and C sharing, person B not sharing. B and C sharing, person A not sharing. And then the case where all 3 of them are sharing. And so already, before we even started throwing any numbers in here, the problem gets very complicated, and if you went through and calculated it, it would still be very small. And as you get to more and more people, if you go with this method, the complication gets very difficult to maintain and keep track of. So whenever we're looking at a probability question that got very complicated very quickly, we think, well, maybe there is an easier way. And there is an easier way, and that's calculating the complement. And the complement is, well, when does this not happen? And this doesn't happen when nobody shares a birthday. And that is actually something that's very easy to calculate. And what we do is we find the percent chance of the complement. We're going to get that as a decimal. So when I say percent chance, 50% would be like 0.5. And we're going to subtract that from 1. So we say this question could be also asked, what is the number of students needed so that there is less than a 50% chance nobody has the same birthday? So let's talk about how to calculate that, because it's much more doable. The way that we do that is we say, start the same way. The first person can have whatever birthday they want. The second person, then, to not have the same birthday as the first, has 364 options for their birthday. And so we can multiply by 364 over 365. The third person, then, can't have the same birthday as the other 2, so there are now 363. And we just keep counting down until we find a value that makes this product less than 50%. And so the way that would look is 365, and we don't subtract the number of people. What we end up subtracting is 1 less than the number of people. And that's because the first person was 365, the second person was 364, so 1 less than, we subtracted 1, not 2, to get the second person. And then that's over 365. And this equals, well, it turns out there is a terminology for this product of 365 times 364. It's called a permutation, and we write that like this, and it's going to be the number of people, so 365 things permuted x ways, and then the denominator is just 365 multiplied by itself x times, which is a power. So now we have a nice equation using a variable, which is 365 permuted x times over 365 to the x. And we want to find out what value of x, the number of people, gives us something less than 50%. Well, this would be impossible to do by hand. There are some ways to do it on a calculator, but I decided, because I'm using a computer and not a calculator, a nice way to solve this would be to use a computer program. So the way that we're going to do that is I've written a computer program, and here's my program, and this program is going to do this calculation, and I've told it to stop when the answer ends up being greater than 0.5. And so, or answer is less than 0.5. And when I run this program, it's going to spit out all of the calculations. And here are the calculations. And as you see, as we go through here, when there are, for example, 10 students in the room, there is a 88% chance no one shares a birthday, so a 12% chance that they do share a birthday. So we keep coming down, and we're looking for our final answer. And finally, when there are 23 people in the room, there is a 49.3% chance that nobody shares a birthday, which means there's a 50.7% chance that at least two people share a birthday. And so the answer to our question is 23 people, which is a very surprising result. Most people, when you guessed, probably guessed something much higher than 23 because it is very surprising and unintuitive, but the math holds up for our answer of 23.